Number 47. If the half cell containing 1 molarity of iron 2 nitrate in galvanic cells Y and Z is replaced with a half cell containing 5 molarity of iron 2 nitrate, stop it. So basically the concentration, right? Concentration is going up. What will be the effect on the cell voltage of the two galvanic cells? Well, so this question actually requires you to know what's this thing called the Nernst equation. If you're not familiar with it, you might want to review that yourself, right? So basically the Nernst equation, is E cell is equal to E naught cell minus 0.0591 over N log of the anode to the power of, I'll just call it A, and then over the cathode to the power of C, I'll just call it, right? And basically those coefficients, those powers, those small letters A and C, come from the coefficients, right? So if we think about, well, let's do one thing at a time. So I'm going to do one for the Y separately and one for the Z separately. Let's do the Y first, right? So this is the galvanic cell Y. And let's see what's happening. Well, first of all, the E naught value is 1.22. It's given in the table. Minus 0.0591 over how many electrons being tossed around? Well, 2 aluminum becomes 2 aluminum 3 plus, so that's a total of 6 plus. And it seems like, well, that's also gaining 6 electrons. So there's a total of 6 electrons being tossed around. Log. And then what's the anode? What is the one that is being oxidized? Well, that's the aluminum. So aluminum 3 plus to the power of 2, right? Because there's that coefficient right there. Over, and then what's happening in the cathode? Well, that's the iron is being reduced in the cathode, so Fe2 plus to the power of, obviously that 3, so right there. Now, do you really need to calculate this? Well, first of all, you can't because you have 2 missing variables. So you can't calculate it, but the point is this. If you have higher concentration of the iron 2 nitrate, which is going to eventually dissociate into Fe2 plus and NO3 minus, well, 2 of that to be exact. Well, then what happens? This thing goes up, right? So right there, your denominator is going up. I understand this is log, but remember, log of a big number is a big number. Well, not as big, but still, like if you increase log of whatever, like log of x, let's say, and if x is bigger and bigger, well, the value is going to get bigger and bigger. So if you have this right now, where your denominator is going up, then this whole expression right here, well, that's going to go down in its value. So log of a smaller number is going to be even smaller number, perhaps maybe even negative, right? So basically 1.22 minus, we're subtracting less than what we used to, right? Because the whole value goes down. Your denominator is bigger, overall value goes down. So you are subtracting a smaller number. That's why overall this is going to get bigger. So that's why the voltage in cell Y is actually going to increase. And then, well, let's think about the galvanic cell Z then, right? So for Z, what's happening in Z? So let's write the same thing. E cell is equal to E naught value. We calculated it already from question number 45. If you missed it, just refer back to my other video. 0.78 it was, right? So 0.78. Once again, that number really doesn't matter, but minus 0.0591 over, you don't even need to know what this n is going to be, but let's just do it for the sake of practice. Well, there are 2 electrons being tossed around, so that'll be 2. And then, kind of running out of rooms here, so let me just take that away. And then log, what's in the anode? What's being oxidized? That's the iron, so iron 2 plus. And then the reduction, that's copper 2 plus. Okay? And now, once again, what we have is we have higher concentration of the iron, right? From going from 1 molarity to 5 molarity. So your iron concentration goes up. In this case, the numerator goes up. What does that mean? Your overall value right here, that's going to increase. So your overall value here is a bigger number. So long story short, you're doing 0.78 minus a bigger number here, right? Which means you're subtracting more, so overall that's going to go down. So this is why the voltage in Y is actually going to increase, but the voltage in Z is actually going to decrease, which is what makes answer choice C correct, where it says the voltage will increase in the cell Y, but decrease in cell Z. That's the right answer.